Good evening, good morning, good afternoon, whenever you're watching this. We are live tonight. It is Thursday, 7 p.m., and I have a special guest this evening, Doug from Idaho Falls area. I'm in the Idaho Falls area. We're going to keep just to his first name because my geothermal greenhouse videos get over 1 million views, and Doug needs to have his own life. So he is here to walk you through what his experience has been. I believe, Doug, didn't you come over here to my place with your folks a while ago? And that's kind of how we met. And then we've been in touch since then. Or how did that happen? I don't remember our first contact.
Yeah, that's correct. My father-in-law mentioned that there's this gentleman that does these in-ground greenhouses, and piqued my interest. And so he just drove us out there, and it's probably been about a month now since we had that first visit. And we just recently did a second quick follow-up visit crossed some T's and dotted some I's. So my father-in-law introduced me, and then we came out and did a quick visit.
Okay, great. Doug is, I think aren't you digging your geothermal hole this weekend? Is that where you are?
It will be this weekend.
Okay, very good. So I have a whole playlist on gerbil greenhouses, on geothermal greenhouses at ldsprepper.com. That's my YouTube channel, and just go to playlist and click on DIY geothermal greenhouses. You'll find lots of good information in this. We're going to be adding this series of videos with Doug in that playlist. So there'll be a lot of good information here. I do want to thank our sponsor this evening. If you look down below this video, you'll see a link to Greenhouse Plastic. I've worked with these people. It feels like a family business. Farmplasticsupply.com is where I get my greenhouse plastic. They have phenomenal customer service. Just the nicest people to work with, great prices. And if you use the promo code, they have a promo code set up for you, which is LDS Prepper. One word. I don't get any kickbacks. I'm not affiliated with them, other than I really believe in their business, in their people, and in their product. So if you're looking for a greenhouse plastic, go to farmplasticsupply.com. And I was talking to somebody the other day who really wants to get a greenhouse, but greenhouses kits are very expensive now. Actually, this was my son at lunch yesterday. We were just getting done sighting in my thermal scope, and we went to lunch. But at any rate, I suggested to him that he just look on Craigslist or Facebook Market, or when he sees a greenhouse frame around, that he go up, knock on the door, and say, "Hey, would you like me to get rid of that old frame that you're not using?" So you may be able to get a greenhouse at a much reduced price if you, instead of buying a new one, and then you can just get a hold of farmplasticsupply.com and get some plastic there. Also, if you're looking for someone in the Idaho Falls, basically eastern Idaho area, to do your excavation work, I've got Brad Speakman. He's doing work for me right now. He does excellent work. He and his son have a business. He's a retired doctor, a medical doctor, and he's doing excavation work, does great work. He can get that taken care of for you. So take a look at those links down below. As Doug provides links and sources here in this video, I will be posting those below this video in the description section. And he's got a couple documents that he's graciously sharing with us, and I will get copies of those, put them up on like a Google Drive, and give you a link down below. So everything that we discussed tonight will be available for you in the description below this video. All right, so Doug, we get lots of questions going right now, but before we jump into the questions, let's just have you kind of tell us how you get started on this journey, why you wanted to do this, how you found that this was a solution, and how you got to deciding that this is the method that you wanted to use.
Gotcha. Yeah. So one of the things as far as with the greenhouse, I started to see people. In fact, I think it was my father-in-law that said, "Hey, I know this gentleman that does in-ground greenhouses," and I thought below grade below the ground, I'm digging a trench. And I come to find out that that's a Wallapini. That's the style of greenhouse today. So this is what I had in mind. I was just anticipating extending my growing season about a month before, maybe 2 months after, and just getting a little bit more of an extended growing season. And so that's all I really knew about it. Now I had a friend who started to build a year-round greenhouse. And I had no idea that he was building one and checked his out. And I said, oh, this is really different than the one that I'm looking at building. And to come to find out, it's the exact same thing. It's a geothermal, and that's what it was. So at first I just thought, hey, I want something that's extremely low maintenance. So that's why I was looking at Wallapinis. But the more that we talked about that, you're really minimizing the amount of your grow space. And there's a lot of limitations to what that offered. And so I'm trying to go as minimal as I can on power and just be as off-grid as I can. But that was really my first thoughts, was trying to be able to get a system that just is, hey, I'm going to extend my grow season. Now I've got other garden spaces that are my summer gardens that I'm working on. And those are, will be much bigger than my greenhouse that I'm putting in. But just to be able to supplement that, that's when my father-in-law had me come out and visit you. And that opened up my eyes to, oh, wow, this truly is a year-round greenhouse. And so being able to go through your greenhouse, spend about 2 hours with you and go through that really piqued my interest. And so I said, hey, let's go with this. Now, to be totally honest, when I looked at that, I thought, oh, the greenhouse will cost about this and it'll cost about this. You're going to see some numbers today. And once you start to add it up, I put some little algorithms in my Excel sheet, and I was looking at the price. I'm like, you need to be committed. Like when you do this, it's not this small commitment. And it was good for me to go through that process and understand, okay, here is everything. Now, it does require a lot of, I've had to watch your video, other people that, tried to do something similar, and I'm trying to piece these things together. Your video, though, was super helpful. So I just literally watched it from the start to the finish, and I sat there with a Word document, and I just started to type in my notes. And that's what I've gone through. So that's really the short background.
Thank you. I think you're referring to the video called The Ultimate Greenhouse Walkthrough. Is that the one you were talking about?
Probably that one, yes.
Okay. So I do have, like I mentioned, the playlist on the geothermal greenhouses. I always recommend people watch the ones that are called Ultimate Greenhouse. I think there's 3 videos called Ultimate Greenhouse Walkthrough, Ultimate Greenhouse Design, or whatever. Watch those 3 to give you a really good concept of different ways of doing this. All right, so let's go ahead and do this. If you can start walking people through your process. I know you put that in a Word document. So if you'll go ahead and just share your screen. And this is really going to help people, because people, where do I start? How do I get started? Where do I get supplies? Where do I put this? How do I orient it? All those kind of things. So I don't know if that's all addressed in your document there, but if it is, that would be great. So I know, I've talked to a lot of people, and I've helped a few hundred people put in geothermal greenhouses all around the world. But when you came to me the second time, earlier this week, I guess, just a few days ago, and you had your laptop with you and all your notes and your diagrams, I thought, okay, this is the guy who has all his stuff together and is somebody that could really, really help others going down the same path. So I appreciate your detail and your commitment to this, and I think it's going to be a big blessing to everybody watching. So let's have you go through your items there. People may get questions as you're going through this. Please post your questions, and we'll get back to your questions here after Doug goes through this. So let's go ahead and they're seeing everything full screen there. So go ahead and just kind of tell us, kind of go down this list, walk us through this.
Yeah. So basically I broke this up into, here's my pre-planning. This is when I start to dig my hole, what's going to happen, and then a little bit after that. So essentially, the first thing you want to do is, location really is everything. You do need to consider, this has to be east to west, depending on where you're at. It has to go east to west on the length of your greenhouse, because you need the most sun exposure on the southern side of your greenhouse. So the width needs to be east to west. The shortest is north to south. So keep that in mind. The other thing that I was considering on this is, you also need to understand that you've got to get power out to this greenhouse and you've got to get water out to the greenhouse, and it has to be below the frost line. So keep that in mind. I ended up moving my greenhouse closer so that I can tap into my main water line off of my well. So when that runs out, I could have put it, another 80 feet into the back of my property, but that would have just exponentially increased some of my costs to be able to get stuff out to it. So consider your location, but you definitely need that widest orientation to be facing the southern sun so that you get the most sun during the winter months. And the other thing is I've got, neighbors on different sides, just looking at hazards, looking at trees, just so that you're not getting shaded. There's no fire pits that are next to it, so that you're going to burn your poly. So those were my basic, first is pre-planning things that I did. All right. From after that, basically the greenhouse that I have is a 20 feet wide by 40 feet long. And so I'm marking out with twine markers my space, and really your 5,000 foot view of this is basically you're using the air that you pump down into the ground to be able to warm the ground during the day, and then at night when it cools off, it's going to take that warmed air that's down into the ground and push it in. So most of you should be familiar with that concept, but really it's super basic. That's really what you're doing, is using a fan to pump air into tubes and to blow that warm air out at night. Now, in your summer months, when you switch that, and you've passed your frost warning, May for us is kind of past our frost warning. You roll up the sides and that's fine. But basically that's it. It's just getting that warm air. So for me, the next step that I'm going to do, and this is going to hopefully happen this weekend, is you dig down between 3.5 to 4 feet. And the reason that we're saying 3.5 to 4 feet is you're going to get some settling of the ground. When you dig 3.5 feet of soil out and you pile that up onto the ground, and you're putting tubing and piping and you try to tamp it down as best as you can, it's going to settle eventually. And one other benefit that you can have of only going 3.5 feet is that you can build up to that on the outside. You'll build up 6 inches to that, put some dirt around that, just in case there's any low spots, depending on how you've got water that melts and settles on your property. I've actually got a section near where my greenhouse is where my water settles every springtime or on a heavy rain. And so I'm looking at between the 3.5 to 4 feet, digging down the exact footprint of my greenhouse. And the other thing that I have to do, though, is to trench this water main coming in. So mine will be on the west side of my greenhouse. I'll be trenching directly up from my main line 6 feet down. So depending on what you're using for your excavation, you've got to work around bringing in that trench 6 feet and knowing exactly where that water main is going to come up into the bottom. All right, so once you've got your hole in the ground, you've got this 4-inch EPS insulation. They're 4x8 sheets. You basically put those around the 4 exterior dirt walls that you have. And I know that David has mentioned before, I've got some 12-inch long landscaping staples that I'm just going to press those into the side so that it pins all of that styrofoam up to the walls, so I can start putting dirt in and start laying in my piping. Eventually, once the dirt starts to hold that into place, I can pull out all of those staples and they'll stay up by themselves. Now, let's see here. Just so people understand a little bit about EPS insulation, it's more of an open cell insulation. There's other types that are called XPS, and it's more of a closed cell. Dave and I had a little exchange on this. XPS insulation actually it's closed, but when it goes below grade, it actually holds and retains water longer if water were to get in there. So EPS insulation is what most contractors will use for below grade. All right. I know that somebody had taken a look at temperature sensors. I'm going to take a look at that. Now that I've got my hole, I've got my insulation on the outside. This is when I start to do my corrugated pipe. And I think maybe the best thing for me to do here is to jump in and to show you what I'm doing visually in my layout, because this, I think, will explain a lot of this.
That would be great.
Okay. So what we're looking at is basically a top-down view of my greenhouse. So I've got different schematics, but this is my 20 by 40. And what I have, we're gonna move to this bottom one right down here. So this is a side view of what I'm looking at. I've gone down 4 feet. This is my 4-inch corrugated drain pipe. I'm going to start it down here at the bottom. This stuff that actually comes up above ground. So basically right at this 90-degree elbow coming up to the top is going to be a solid pipe, not a perforated pipe. That'll come up above ground, but I'm going to start somewhere down in here, right at about ground level. I'm going to splice this, and everything below grade is going to come down, and it's going to run all the way over. And I'm going to have these separated by about 18 inches. If you look up here in the top right, these are my 10 rows that are going to be running down off of the side and then across, all the way across my 40-foot span. And I've got about an 18-inch on-center spacing so that each of those pipes will come up. 5 of them will be on one side of my door that's here in the center, and 5 of them will be on the other side. So that's what you're looking at, is a top view here of how those pipes are going to run across the greenhouse. One thing about piping, David has mentioned originally, you had done 10% of the cubic volume in linear feet. So what you do is you take the width times length times height, and that gives you your cubic volume. So with this greenhouse, it's 1,800 cubic feet, cubic feet in volume. And you take 15% of that, and that's going to be essentially 1,200 linear feet. So get your volume and then multiply it by 15, and that's going to give you your linear feet for how much tubing you're going to put in the ground. So this one in particular, if I take this tube and I run it down and it's 40 feet going across the bottom, here we'll zoom in for you. This one's going to run 40 feet. It's going to turn. It'll go up 12 inches to the next layer of dirt. It's going to run 40 feet over, turn, go another 12 inches up and turn, and then go up underneath my housing. Those 4 spans, each of those will be 120 feet. You've got 40, 60, 40, 80, and 120. Because I have 10 of those, that's 1,200 linear feet, which is 15% of my cubic volume. So that's to give you an idea of how I got to that. And to be honest, it just worked out perfectly that 10 of those running across, wrapping it 3 times equaled 15%. So
that's beautiful.
Just a nice coincidence that that's how that all works. So that's what I'm going to do. Now, to give you an idea of what I'm going to be doing below grade here. So these 10 pipes are going to start on one side and run over. And I'm going to run little stakes. I'm going to put stakes in between these to keep them nice and straight. Once I get to the end down here, and I'm going to have to turn this. So we'll just show you down here. I'm going to turn this down here at the end. I'm going to put a stake in the ground. I'm going to put maybe 6 or 8 of them across here that have a 12-inch marker on it. So I'm going to stake it down so that I've got a 12-inch space and it's going to stop. That's where I'm going to fill my next layer of dirt all the way across this. Then I'm going to wrap my pipe, run all 10 of them across, and then put another set of stakes in, wrap that pipe, run it back across so that I know I've got that nice, at least 12 inches of space. Now, David, last time we talked, you had mentioned that a good rule of thumb is 18 inches of dirt above your last pipe.
Yes, I like 18 inches because I may be digging down for irrigation, or I may have roots going down because I don't with my grow boxes or my soil beds, and I don't want to be bumping into my tubes. So actually, the closer the tubes are to the surface, we'll address this a little bit later. The warmer the air it generates, because the warmest air is really at ground level because the sun is heating up that soil. So if you have your tubes inside, in the footprint of the greenhouse, not outside, but basically underneath the greenhouse, your warmest soil is going to be closer to the surface. Your more consistent temperature soil will be deeper down, but that'll be colder soil. So I really like the 18 inches. You could go maybe 12, but I certainly wouldn't go any less than 12. And I think your detail here, Doug, on measuring the distance between the pipes and staking them down and using your stakes to make sure you're 12 inches above the row below you is really going to make you successful, because you're making sure that you have the maximum amount of soil surrounding each of those pipes. So as the thermal energy moves from the soil into the pipes to the air moving through the pipes, you'll get the greatest exchange there. So good work on that detail.
Okay, so this is essentially, I will have started my bottom row, wrapped up to my next I may adjust this 18 inches to 12. We'll see, because that would give me additional 3 inches in between each of these layers, but we'll see what happens this weekend. So once I get to that last row on top here, and it's going to wrap around, and I need to come underneath my 50-gallon drum. On this schematic here, you're going to see, you're like, wait a minute, all of these lines just end on the end. Well, I haven't taken the time to show this top row, but every single one of these 10 pipes is going to need to converge underneath this pipe at the end. So my last row over here is going to turn every single one of these, and you're going to have just a large ball of pipes, all 10 of them, that I'm probably going to find some rope and just tie them together, get them underneath that drum. So all of them are going to eventually stick up out of the ground, and those will all fit underneath that 50-gallon drum. The depth of that just needs to be far enough into the ground that you've got a good seal, that nothing is down in there. You've got a good seal so that when you're forcing air, this is my fan, my little block fan, when you're forcing air down in here, that the air doesn't escape out. So it just needs to be deep enough in the ground. The bottom of this barrel will be cut off. It'll be a completely open bottom of the barrel. The hole on top of this barrel will be big enough, just enough to get that fan. I've got an 8-inch fan. So I'll put a hole big enough as I'll measure the diameter of that fan and make it just big enough for that to settle down on top of that 50-gallon drum. And then if you're curious what this is, so this is a pipe that'll go on top of that, a large irrigation pipe that will extend to the height of my greenhouse within maybe a foot or so. But that's going to allow the intake to take the hottest air from the top of the greenhouse down into your tubes and to push it throughout the below grade piping system. So that's what that is just a large irrigation pipe that I'll put on top of that. All right, let me jump back to that Word document and see where we're at in our progress. All right, so we did our math here. There we go. That's how I got my 1,200 linear feet of 4-inch tubing. I'm doing that 18-inch on center. My water line is going to go below grade at 6 feet. I've also got my wiring I'm compensating for. I'm doing it on the west side. All right, we answered the question on that one. We've got them in straight rows. And, oh, this is a really important thing that David has mentioned. So when you lay your rows down, that first set of 10 rows are going to run out across and get to the other side. As you start to put your dirt into the ground, put your dirt first in between your 10 pipes, and then stomp that, tamp that down as much as you can. Get everybody with their feet or whatever you need to tamp that down, so that the next time you put your second layer of dirt on there, that dirt isn't going to crush your tubing. This 4-inch tubing is not super, I mean, it's for below grade, but if you put this much soil on there and start stepping on it and things like that, just tamp it down in between your rows first, get that nice and solid, put another little bit of soil on that, tamp that down just so you've got a nice solid base in between your rows. And that will hopefully prevent that any of that collapses. Okay, we're going to converge underneath that 50-gallon barrel. We already showed that. And then the fans. I've got an 8-inch fan for this. I know that David, in yours, you had a 10-inch fan, but anything you'd like to say about just fans? I think an 8-inch fan should work really well for what I've got.
Yeah, so you're doing a 40 by 20 greenhouse?
Yep.
Okay, so I really think a 6-inch fan would work fine. The reason why I say that is because I've got a 10-inch fan in my greenhouse, and I'm on the lowest speed. There's 3 speeds, low, medium, and high. And then I've got a regulator on that. So I'm at half of the lowest speed. So that fan's going to probably last forever because there's hardly any stress on that motor. My experience with that fan, it's so powerful and so good that for a 40 by 60, I mean, a 20 by 40, I think a 6-inch fan would work. Certainly a larger fan is going to cost you a little bit more money, but you're running it at lower RPM, so there's going to be less wear on the motor. So easily 8-inch to 6-inch fan for a 20 by 40 greenhouse. I haven't built a larger greenhouse than that. I've got somebody who's building another greenhouse, and they're doing 2. I think he's doing a 90-foot greenhouse. He's doing 2 8-inch fans, which is plenty for what he's doing. So with this particular brand, the can fan, it's my favorite product. If I was going to recommend a brand, I would recommend the professional version of the can fan. because the professional version actually has a collar on it that you just cut a hole and you drop it in and it seals. If you don't get the professional can, then you have to get the blower and a collar to seal on the 55-gallon drum.
So I ended up going with the 8-inch specifically for what you mentioned, is to have a lower load on that so that I can get a longer use out of it. So I actually bought two. One is a backup. So an 8-inch fan to be able to just put as little demand on it as I can and hopefully get the longest lifespan out of it as I can. So I know that in your greenhouse, you also have a regulator. So you've got yours on low and you've got it at half speed. Mm-hmm. And so it's basically a quarter speed of what the fan actually would do, quarter of low. So it's pretty low. All right. So now basically what we've got at this point, we've got the styrofoam is around the edges. We put all of our piping in. We've got we've made space and put in our water faucet, or however I've got water in there, put my water in there. I've got my 50-gallon drum. All my pipes come underneath the bottom. I brought my pipes up this side. And just as you're working on this, I'm going to be putting pieces of like a plastic bag and putting a rubber band around the ends of those pipes, just to prevent rodents and other things from crawling in there as I'm working on this, because I know it'll take more than one day. So I'm going to seal off all of these pipes. Anything that's going to be exposed while I'm gone or go overnight, I'm going to seal just so I don't have any little critters climbing down and dying down inside of my piping. So just keep that in mind. Now
let me share experience. So I didn't initially cover the ends of my pipes as I had built this, and they were laying out for a while, probably a few weeks. Then I got the greenhouse built. I put the fan on, and when I put the blower on it, I blew out an entire mouse nest with the whole nest, the 3 mice. They just kind of came shooting out of the pipe. So they will definitely get in there. So make sure you cover up the ends when they're not laying open, so little critters can crawl inside your pipes.
And then right at the top here, this is actually a separate 90-degree elbow that I'm putting up here, just so it kind of directs the air out. In reality, whether it went up, straight up or it comes out at a 90-degree elbow, the air is going to come out into the space. I will be putting a little fine mesh on here that's going to keep bugs out, at least larger bugs in there, or keeping like hornets from flying in there so they can't, build a nest down inside of my piping. One of the things to keep in mind, so this piping, I ended up buying my piping in 250-foot rolls. So I just bought 10 of them. Oh, actually, I bought that for me and my father-in-law. So 5 250-foot rolls is 1,250 feet is what I ended up getting. So instead of buying these really expensive splices that go in between your pipes, you can just take about a 6 to 8 inch section, take a hacksaw, cut a little 6-inch piece off, and then splice it, cut it right down the spine. You fold it in on itself, slide half of it into one side of your tube, and then bring your other tube and slide over top of it. And that's the splice. Those are actually almost identical to what you would buy in the store. Otherwise, if you buy that separate little collar that joins them, they're like $7 to $10 a piece. And I would need something like 20 of them at least to be able to complete this. So it saves you about $200 by just using the pipe itself as your splices as you're merging these pipes together. Okay, so now that I've got that, all of my below grade is essentially done. And I'm going to come to my above grade. Let's take a look back here. So ordering the greenhouse. I ended up getting my greenhouse from OBC Northwest. We can put a link in here to that greenhouse. It ended up costing me $4,500, but we ended up driving and picking them up in Oregon. The shipping on that was a little over $2,000 to ship that in freight. So shipping right now is crazy. I actually ended up driving to Casper, Wyoming to pick up my pipe because it saved me about $700 on my pipe as well. So let your fingers, scour the internet, pick up the phone and call a variety of places. But OBC Northwest, when you get this document, you can click on that hyperlink and it'll take you to that page. That's where we ended up picking up the frame for this greenhouse. So it's a semi-Quonset greenhouse. Now the sidewalls on this are 6-foot sidewalls. I know that David has a friend of his that did 4-foot sidewalls, and going 6 feet just allows the internal space of that to be significantly more spacious and to do a little bit more in that. Do you have anything to say about that, the sidewall height David?
Okay, so I have I bought a kit, and I bought it from OBC Northwest. So you can go to obcnw.com. And by the way, when you go there, don't just look at kits on their website. You want to call somebody. At least my experience, maybe yours was different, Doug. But you want to actually talk to somebody and get a salesperson on the phone and tell them exactly what you want and what you don't want. So you need to have kind of a good idea when you get started, and of course ask them lots of questions. But the reason why I went with the OBC Northwest is because the county ag extension director suggested that I work with them because they have really, really sturdy greenhouses. We get 66-mile-an-hour winds here at our property, and that greenhouse has not budged at all in the wind. I mean, not swayed, not moved, and I don't have any of the extra supports in there, and my ribs are 4 feet apart. So when I bought mine with 6-foot sidewalls, which means you get an 8-foot pipe and 2 feet goes down in the ground. And then I bought another friend at the same time, a friend bought his greenhouse with 4-foot walls. Now in my greenhouse, I'm growing trees, loquat and avocado and oranges and lemons and limes and grapefruits and so forth. So I wanted the extra 2 feet of headroom. So 4-foot sidewalls will give you 9.5 feet at the crest. 6-foot sidewalls will give you 11.5 foot at the crest. I just wanted the more room, and it feels really roomy for me. You know, my shoulders are the same height before the roof starts coming in. So I like the 6-foot. My friend got the 4-foot because he wanted to have less cubic space to keep warm. So both work, just depends on what you prefer. Although he did tell me he wished he had gotten the 6-foot sidewalls.
And inside of mine, I'm going to end up building a, not totally a T-frame, but a square trellis system. So I'm going to have the large T-frame running through the 2 northern grow boxes in mine. And so I want the height at least 6.5 feet inside of there. And those will be on the north end, and that ridge height will give me the room to be able to grow higher within that space. So to be able to get those T-frames up a little bit taller. So here's the OBC Northwest. I actually contacted a company out of Utah as well that they sell something very similar to this semi-Quonset greenhouse. And their price was, when they weren't super helpful, they were giving me just very vague pricing, but even the vague pricing gave me was more expensive than OBC at least the couple of weeks ago. So
yeah, I also contacted that company when I was looking for a kit too. I was my same experience. It just wasn't a very good experience. At that time, their pricing was less, but I didn't have that good vibe. So I just went with a different company.
Yeah. So basically when you get your frame, your all of the stuff for your greenhouse, you're going to get your rods, poles, all of that type of thing. If you want to be able to see the interior of that, you can watch David's video. It does a nice walkthrough. You can see the interior of the poles and everything. But basically, as I begin building this out, I'm going to be very precise as I can in setting my poles first. So I'm going to take and dig. It's going to be 22 holes in the ground, 11 on one side. In fact, if I zoom in here, you'll be able to see these are my 4-foot on center posts that are going to be 8 feet tall, and they're going 2 feet down into the ground. So I'm going to dig all 22 of those holes and get all 22 of those posts set in the ground. So I'll get them down. Once I get one into the ground, I'm going to get it right at the 2-foot mark down below grade. And then I'm going to take an 80-pound bag of concrete and pour into that hole and get that leveled. So I'm going to take a really long level and get it vertically leveled. I'm going to set my second pole in next to it 4 feet away. And then I'm going to put that level across the 2 and make sure that those 2 are perfectly level. Get the concrete in there. And we talked just the other day with David, instead of pre-mixing your concrete and doing all of that work, he said, just throw your concrete in there dry. And if you want to throw a little bit of water on top of that, but it will set itself. And for what you need, 22 bags of 80 pounds of concrete, even though it may not have the 100% structural strength of a pre-mixed, really well done concrete, you're going to have lots, and I mean, a lot of weight holding this thing in the ground. David, you mentioned your other greenhouse, which is just a rounded greenhouse, doesn't even have supports into the ground. and it's withstood the 80 or 60 mile an hour winds just fine. So I think this 80-pound bags and each of those things, dry concrete, it saves you all that labor and time of having to pre-mix that, and then just pour water over the top, let it set down in there, and all of that will set up. So I'm going to get all 20. Oh, go ahead.
And let me just mention, if you do a search, because I don't want to take, I don't want to share my screen because it just makes it more difficult here. But if you just do a search on your favorite search engine and do a search for two-way pole level, so a two-way pole level, then this is what I use. It is so easy. You strap it onto the pole, and it's got the left, right, up, down, and so you just get that pole set. It'll show you exactly where it is, as far as left, right, up, down, forward, back, whatever. It's super fast, and you can set the poles very quickly. So I recommend a two-way pole level. I got mine at Home Depot.
Gotcha. Good. Thanks for that note. Okay, so I'm going to get all of these boards in, or sorry, all of my initial framing in. Once I've got that in, I can go ahead and start putting in right across the bottom. I'm going to have a 2x6 treated lumber that's going to run around the bottom. So I'll zoom in here. This is a side view of my greenhouse. So everything that's in orange is treated lumber. So I'm going to have a 2x6 that runs along this end, and then that 2x6 is going to run the full 40 feet length all the way back to the other side. And the way that you're going to want to design those pieces of lumber is you're going to want to make sure that they come together to where your split, where these join, is in the middle of one of your 4x4 posts, because you're going to need to put an extra, well, here, I'm just going to create a quick little version of it. You're going to need to put a little extra piece of 2x4 here, or 2x6 here, and nail it in to the wall, into that other 2x4 to get it solid. So measure out your 2x6s. There's going to be one there, and there's going to be one right up there. Measure that out so that they're halfway in between your 4x4 on center posts, and that'll make things easier. The very bottom is going to have a 2x6, and actually I'm right up here at the top, I'm going to have a 2x4 that runs all the way around your greenhouse. So you're going to get that set. Now, when you're setting this 2x4 post in here, it's going to go, basically your post that comes up, you've got the bending frame, that basically the arc that goes all the way over top of this, that will slide in your post first. And then once that's slid in there, then you can put a bolt through your 2x4 and secure all of that together. So first goes in your top support frame, goes into your pole, and then bolt it in. But all the way around this, you're going to have a 2x4 of treated all the way right at the 6 foot mark, right where it bends, and then you're going to have a 2x6 around the bottom. Just so that this doesn't get too many questions here, I know that David, with his 4x4 posts, these are the end of my greenhouse. These are 4x4 posts that I'm going to trim to match the angle of the roof. I can only find, I think these are 12 foot. I can only find 12 foot 4x4 posts right now. I know that David, you went 4 feet below grade. I'm going to get 12 foot posts and put them in there. And what I'm probably going to do is take a 3 to 4 foot steel rod, drive that down into the ground, and then just staple or band that together onto my 2x6, the bottom, just so I've got some structural support down there. So you're going to have to adapt some of this based upon what you're doing. I can't find as tall of posts here, so I'm trying to modify this so that I've got some structural support going down into the ground. On the end of basically, I guess we could run through the kit of what you're going to get with your greenhouse. Essentially, you've got all the framing that you're going to build this with, which is all of your metal rods, tubings, and clips, and everything that's going to hook it together, and the bolts that are going to hold it together. That's the basic structure. In addition to that, you're going to get the poly film that is going to wrap over top of this. And once I've got my frame built, we're going to start on one side. I'm probably going to take tennis balls and wrap inside of my poly. I'm going to put a rope around that, and we're going to throw the rope over. And we're going to slowly start to feed that up and over the greenhouse, and have probably 6 or 8 friends of mine help me to start to pull that over. We're going to grab a couple of push brooms, and we're going to use those to just guide them over. And we're going to move that over across the entire top of the greenhouse. Now, there's a lot of little things. Before I get that poly on there, like when I'm down here in on this 2x6 post in the very bottom, on the outside of this, I'm going to have a piece of plastic. Maybe I can just draw a little line here. A piece of plastic is going to come down and then down a foot into the ground. We're just going to color that. So that little piece of plastic is going to come down into the ground so that it's protecting my 2x6 from mold and other things. And then I'm also going to have my animal netting that is going to be from this top frame. So this 2x4, this 6, there we go. The 6-foot sidewall, I'm going to have animal netting that goes from this 2x4 up here will be stapled to the 2x6 on the bottom, and it's going to run the full 40-foot length all the way back. Because this greenhouse, you're going to want to buy the one that has the roll-up sides. And in David's video, he mentions a really important note. When you go to roll that up, you're going to roll it backwards on itself so that when the water runs off of this, that it doesn't catch underneath into a pocket that actually rolls off and just sheds off to the outside. So keep in mind that you're going to roll it inside towards the greenhouse as you roll it up. So that's a little bit of a note. I think we're going to get into more granular detail about what that's going to look like once I get my built. We can show kind of that step-by-step process of what that's going to look like as far as building that out, because people, I think it'll be more helpful that way. So, okay, so we've gone through, I've got my 2x6 treated lumber on the bottom. I've got my 2x4 treated lumber 6 feet up, and that'll run all the way around the frame. I've got my animal fencing in. There was a question that we just talked about is the end walls. We're going to do a permanent insulation. So we're going to have 2-inch EPS foam insulation on my 2 end walls that will always be there. And I think I'm just going to use the plastic for now and run the plastic. So on your ends, we'll just jump back here. Running up your side all the way around this curve, all the way to the other side is going to be a channel for wiggle wire. So your plastic is going to come from your top, is going to nest into that wiggle wire, and your big sheet that goes up the side is going to nest into that wiggle wire as well. Inside of that is where all of my frame is going to be, my treated lumber, my 4x4 posts we're looking at here that are vertical. And then I'm going to have foam insulation. Actually, that's what all these gray blocks are for. All of these are 4x8 sheets of foam insulation to give me an idea. I'm going to need 6 sheets about to fill out each end. So about 12 sheets to fill out both ends of the insulation. One super important note here is insulation in general. So if you're going to be able to, if you want to be able to grow year round, you're going to need insulation on the east and west walls, and you're going to need insulation going from the northern wall all the way up to the very cap. So this is what you're seeing here. I've got these angled pieces that are running around. These are actually 4x8 sheets of foam and 2-inch foam insulation that are going to run all the way around. I have a friend that built a greenhouse using that it's like 10 times more expensive, but the polycarbonate paneling. And he didn't put insulation on the back wall, and he couldn't regulate his temperature at night. So he had to take out about $3,000 worth of polycarbonate paneling and put in insulation so that it would be able to regulate the temperature better during the winter months. So keep that in mind. You're going to be putting 4x8 sheets of insulation on your north wall all the way across that 40-foot length, and they're going to wrap all the way up and around. You're going to have to cut one short. It's about a foot high. I'll just put a little note here, about a foot high here. And then you're going to have about a full 4x8 sheet running right there. So one full sheet here, another about a 1 foot piece here, and then another 1 foot piece right at the bend. And then I think you can do, it's either 2 or 3 sheets that are going to run up on the top. I think I needed 35. I was trying to total this out, somewhere about 35 sheets of insulation to be able to wrap that around. And that's in addition to the 4-inch EPS insulation that's going into the ground. Currently, I know those 2-inch 4x8 sheets of insulation at Home Depot are going for $26 a piece. So keep that in mind. That'll be one of your bigger expenses, is to do that insulation.
So this insulation is absolutely critical. It's essential if you're wanting to grow year round. We're in zone we're in zone 5A or 5. So with my first attempt at this, I did not have the styrofoam insulation on the east, west, and north side, and I lost 18 tomato plants in one night. once I got the insulation in to keep the warm air from the geothermal tubes into the greenhouse, then I have never had a problem, never had it freeze inside the greenhouse. So this is great. I think we want to stop here. We've got about 11 minutes before we're at the top of the hour. Is there anything else before we cut this off that you wanted to show them before we get into questions?
I'm just going to briefly show you how I've got my garden boxes in here. So I'm following the lighter gardening method. These are my 2x8 garden boxes are 2x8, which is 8 inches deep. They're 18 inches apart. And these are my drip line pipes that are going to be running through there. All of that is in your videos. So these are my 3/4 inch poly pipe that I'm going to be drilling all my holes in to do that. And then this little orange diagram here, that's going to be my trellis system or my T-frame raised, where I'm going to put the strings down so I can do vertical growing. That's the basics of it. Other than these are about 3.5 inches, 3.5 feet apart between these two rows. And then I shortened this one on the end because I won't be going over there. I'll be able to pick from this inside row. But to be able to get that 3.5 feet, at least on these inner 3 rows, I shortened the outside because I'm only 20 feet wide. Other than that, I think we're good.
All right, so I've got some questions here. Is there a way to passively heat up the earth during the hot summer weather so as to have a greater heat reserve to draw from during the winter? That is maybe 60 something degrees instead of 54. So what I've done, and I'm sorry, I couldn't grab the name of the person who asked the question, but thanks for the question, is I run my geothermal 24/7, 365 days a year, because at night it's blowing the warm air into the greenhouse, keeping in mind that I'm growing year round. And during the day, it is doing exactly what you're asking here. It's taking that hot air, just like Doug mentioned, that intake pipe goes all the way up to the top of the greenhouse minus a foot. So it's a foot below the ridge, a foot below the top of the greenhouse, because he's not exactly in the middle of the ridge. And it's actually warming up that soil. So yes, you can warm up that soil during the summer and during the day, even in winter, you're warming up the soil by letting that run 24/7. So I don't have a high-low thermostat that will turn the fan off, because I'm actually using it to warm the soil during the day and then to warm the greenhouse during the night. Any other thoughts on that, Doug?
That's an interesting concept. I know that you had mentioned that during the summer you're rolling up the sides, and I wasn't sure if you ran your fans all summer long or not. I was anticipating once the frost warning is gone, that I was going to shut down most of my fans and allow, one thing we didn't even cover were the high tunnel vents, right? On the sides of each of the east and west walls, I've got 30-inch high tunnel vents that are temperature hydraulic. So there's no power going to them, but they're temperature sensitive. So when the temperature gets up, that hydraulic opens up, and it opens up the ends of your venting system so that it cools off your greenhouse. And
you had the people will remember, or maybe show, those were the square block over the door. The yes. Black square over the door is the automatic louvers. And I actually got those from Agricultural Solutions. I think you and I have the same size, like 32 inches. It was the largest ones that they have, and it works really well over a 36-inch door or 34-inch door or whatever it is. So those are critical in helping to regulate the heat in what I call the shoulder months. So between winter and spring, when it's still freezing at night but gets really hot during the day, you need to be able to regulate that heat. Those do it automatically for you. All right, so Helen asks, what are the overall costs to install? Do you have kind of a thumbnail of 20 by 40 greenhouse and the styrofoam, the PVC, the kit? I don't know if if you do excavation separate. We will share his spreadsheets. He's been gracious enough to offer that, and we'll also share his Word document. So I'll have a link below after I get that information from Doug. Yeah, I'm not completely finished with my spreadsheet, but right now I'm sitting at about $11,000, and I'm doing the excavation myself.
And so it's about $11,000 where I'm at. When I'm adding in my wood, it actually is going to go up a little bit because I didn't buy, at least in this part of the spreadsheet, I didn't have the 2x6s around the bottom and the 2x4s up around the frame and those big 4x4 posts. So that's probably going to add another $500 to the cost. So it's going to be, my guess is once I get this, once I get the a couple of other things, it'll be about $12,000 for the greenhouse.
And what was your kit cost?
The kit cost was $4,600, but we went and picked it up, and we ended up spending, between me and my father-in-law, we split the cost, but it's about $1,000 to go pick it up ourselves. They were wanting in the neighborhood of about $2,100 to have it shipped to my house.
Yeah, so that kit price has doubled. My kit for that, my price for that kit 4 years ago was $2,500. So it's gone up like everything else. Okay, it's just what it is. So it's going to be cheaper today than it will be in 6 months. So again, another way you can cut costs is if you can find an old greenhouse that the people are no longer using, get that for nothing or pennies on the dollar, and then go to farmplasticsupply.com to get the UV protected 4-year warranty 6 mil greenhouse plastic. And because it's going to cost you some money, but I tell you what, being able to walk out there and pick a tomato on Christmas morning, or my wife just picked some onions today, you just can't replace that. I mean, there is a cost to that, but there's also a cost not being able to do that. So either way, it's gonna cost you. All right, question here. Doc Michael asks, how deep is stable soil temperatures?
So the reason we're going down 4 feet is because when the greenhouse brings in all of this thermal air, it's going to heat that up. We're not too concerned about going deeper. So in reality, we're just working within that 4 feet because it's just less cost to excavate. Now, we talked the other day, if somebody were to say, hey, well, I'd like to put my tubes up into my greenhouse, but I need to run them out into a separate area, you're going to need to go down 8 feet because you're not superheating that air above it. You're going to have to go at least 8 feet down to be able to run your piping out because you've got to get below that frost level. So the benefit of doing it right underneath your greenhouse is you're pulling from dirt that's already been heated and warmed. So I think the 4 feet is just a good measure, especially when I'm looking at wrapping those pipes back and forth. It gives me a good 12 to 16 inches in between each of those pipes, which is a perfect distance to get all the linear feet that I need. Yes.
So I don't want to go any deeper than I need to. I don't like to spend any more money than I need to. I don't like doing any more work than I need to. And 3.5, 4 feet will work really, really well because it's underneath the greenhouse and the greenhouse is keeping that soil warm. Kathy asks, is this a home or a greenhouse? What we're talking about here, Kathy, is a greenhouse. However, as was mentioned in the comments, many people heat their homes with geothermal air just like this. So you could do the same thing in your home. Probably in most cases, you're not going to have the geothermal tubing underneath your house. And so in that case, to have a consistent soil temperature, you'll probably want to go down below the frost line. Here it's about 4 feet. So here we would go down 8 feet. So we'd have 4 feet of soil around those pipes. Helen asks, what do you need to consider when you have a high water table? So do you have a high water table at your place, Doug?
I don't. I bet I could go down at least 8 feet and I probably wouldn't find water. I know my well goes down at least 200.
Okay. So we have very, very successfully done this with a high water table. The way that you can know is just dig a hole as deep as you plan on putting your pipes and seeing if any water comes in. Now, depending on what time of year you dig that hole, you may have water or you may not. In winter, you probably won't. In spring, you might. Or in my case, in Doug's case, we didn't have high water table at all. However, how we've been able to successfully do this is instead of using perforated pipe, which is, in my opinion, is very, very important to use perforated pipe. And so instead of using perforated pipe, if you have a high water table, is use solid pipe. And then you would want to make sure that you seal those connections so that you don't have leaks. So what I would do is I would make sure that that seal is high enough, or that joint is high enough above the water table so that, well, actually you wouldn't need a seal. You wouldn't need to have any joints. If you get a 250-foot length, then you can run the whole 250-foot length and not have any joints at all in that pipe because you're using solid pipe.
At some point in time, you would have to joint it somewhere. You're going to need it. I guess you could just say, hey, I'm going to run these, all of my lowest ones without joints. And then once you get up higher, some point in time, you're going to have to splice because you have 10 rows of them going across. So joints are going to have to come into play somewhere, but just work through that as you're dealing with the water table.
I used some kind of a sealant. I'm trying to remember, but I think it was called HVAC tubing sealant. It was kind of a paste, white paste, and I sealed all my joints so they were airtight. So for drainage and condensation, I highly recommend using perforated pipes as underground, unless you have a high water table. All right. Steel Horse asks, are there government grants, subsidies for geothermal greenhouses? Yes, but Doug, did you apply for a grant? Actually, it's not called a grant. It's called the cost share. Go ahead.
Yeah, when they do the cost share, you mentioned that the cost share waiting list on that was probably 18 people, and the time frame on that was at least a year or longer. I didn't want to wait a year longer. I just wanted to go ahead and get it done. Just to give you an idea, I'm trying to find supplies for some of these things, and it's getting really difficult to find them, and everything is going up in price. So I just went ahead with it. I didn't try to get some kind of a cost share. I don't know how much of that $5,000 price tag they would cost share, but we just went ahead with it. So
I think that was very wise on your part because it's not guaranteed. It may even not be probable that your first year that you'll get the cost share. So you've just wasted a year, maybe 2 years, because you can't build until they approve the area you're going to be building this. And by then you may not be able to get any supplies, or the cost would be significantly higher. Just to give you a reference, when I did my cost share several years ago, I got $2,800 for my 20 by 40 square foot greenhouse. I know that the value, what they're paying out now is less per square foot than what I was paid when I did that. So you may, you may save some money, but you may not ever get the cost share, and you may not save money in the long run because costs and things may not be, costs will be higher and things may not be available. Why use 55-gallon drums instead of a plenum?
What's a plenum?
Good. Good answer. So a lot of people will take a big tube instead of the 55-gallon drum, specifically PVC generally, go down maybe a 12 or 14-inch tube, go down, put a T, then down in the bottom, they have another 12, 14-inch, 16-inch tube, and then they run their 4-inch tubes into that. So I looked into that, and it was $1,000 to do that. And I thought, that just doesn't make sense to me. I've got a 55-gallon drum here. I can pull all these tubes into the drum and it works beautifully.
Yeah, so that's me exactly. So I have 3 55-gallon drums that I use for water storage, and I'm just going to take one of those and cut the bottom off of it, and it'll cost me $20 for the barrel.
Yeah, exactly. So we have plenty of airflow going through these tubes in a 55-gallon drum, and we didn't have to spend the expense or the time to use a plenum. Although I have physically helped somebody who used a plenum, and it does work. It's just a lot more work, and it was $1,000 more. Okay, so I'm going to ask you here, Doug, is the fan pushing or pulling air?
It's pushing.
It's pushing. I had tried pulling and I tried pushing, and I get a significantly better result with pushing instead of pulling air. So that's something occasionally people ask. I've thrown in a couple of my own questions here that I thought might be coming up. Ingrid asks, can you tie 10 pipes into one big pipe that goes up into your barrel? So that's basically the plenum idea. And the answer is yes, you can do that. But the 10 pipes fit into a 55-gallon drum, so you don't need to combine them into one. My tubes that go into the 55-gallon drum are probably a foot above ground in that 55-gallon drum. So I probably have close to 3 feet of drum above it. And then I just made sure they came up high enough so dirt and things didn't fall into it. But there really is no need to put them inside of another tube before you go into the 55-gallon drum. So Doug, can you explain why your posts are 4 feet, your ribs supports in the greenhouse are 4 feet apart instead of 3 feet or 6 feet?
We talked about that, and I know that we could have done 6 feet, which would have saved us money if you want to go 6 feet. It's just for the structural integrity. 4 feet is what I did. It does cost a little bit more to go 4 foot on center, but it's just for the structural integrity to make it a little bit more rigid.
And did you buy the extra wind support?
Yes, those are there as well. Yeah, there's
Okay.
it's a 45-degree cross support that runs up to the corner.
Okay. And they also have rails that will go across from side to side to add extra structural strength. And I didn't find that I didn't think I needed them. I also have my ribs 4 feet apart. We get 55-mile-an-hour winds. And for the last 2 years, I have not removed any snow off the top to see if my greenhouse would collapse, because I want to be able to find out, I don't really want it to collapse, but I want to know if what I have works. So I thought 3 foot apart was more money. I mean, I didn't think it was necessary. Even in 66-mile-an-hour winds and heavy snow loads here, I didn't get the additional support structures. The 45s come with it. That's normal. That's not the additional structural support that I'm talking about. And 4 foot across, 4 foot apart has held in 66-mile-an-hour winds and all the snow loads for the last 2 years. So I don't know that I would go 6 feet. Maybe you could, but I know that 4 feet works. Does the lumber and doors come with the kit?
Nope, it does not.
Okay, so source that locally. Let's see. And Tony asks, how large does this scale to? How big of a geothermal greenhouse can you make? What are your thoughts?
It really just depends on how much space you have for one, but really you can multiply the factors on this and put in multiple fans. I mean, really, you can make a greenhouse that's 120 feet, 200 feet long if you wanted to. You would just need the east-west space, but you would need to just multiply your volume factor. So that's that, because I don't think any of us have done anything that size. But it sounds like your friend's doing 2 8-inch fans, and he'll probably have just great success with that.
Yes. So it scales perfectly to any size greenhouse. And that's what's so nice. If you just make sure you keep that 10% in linear pipe length of the cubic space of the greenhouse, minimum 10%, preferably 15% of that cubic space in linear length and put in tubes, you'll be fine. You can make as large of a greenhouse as you like. Any problems with geothermal from underground humidity? So let me address that, because I've been running greenhouses here for 7 years, going on 8 years now. And the answer is yes, absolutely. That's why I highly recommend using perforated pipe. So when you're growing, and by the way, I do use a product to watch my temperature and humidity in my greenhouses, and it's called Govee, and it has an app, and I actually have alarms on the app that show me that will send me an email and an audible alert when the temperatures get too high or too low. I don't know if you can see that. No, it's not focusing. All right, but I'll put a link down below that. I have tried others in the past. I used lacrosse alerts, which is fine, but I can't find them any longer. And this Gobi actually works better. I was having problems with the Wi-Fi reaching through the house and the distance from the greenhouse, but this Gobi product works really, really well. I'll put a link down below, and I highly recommend that for monitoring your greenhouse temperature, because you don't want to get 140 degrees in your greenhouse and burn up all your trees like I did. So what happens is that your humidity, especially during winter, not during summer, isn't a problem, because usually during summer you have the sides up, the doors open, and it's nice and cool. In the winter, you're getting lots of condensation in the tubes below the ground, because you're taking warm, moist air and you're pumping down to the ground, and it's condensing. And so I always have one tube that fills up with water during the winter if I don't keep my geothermal fans going. If I had perforated pipes, would not have that problem. That water would just seep out through the pipe. So condensation is an issue. However, if you keep your fan blowing 24/7, 365, you won't have that condensation build up, and just the air blowing across it will help evaporate that. Costs including excavation, we covered that. Excavation is going to vary. My excavation cost to have a professional excavator was $3,000 just for the excavation. Do you have any pictures? Not currently for Doug's, because he hasn't made a hole in the ground yet. But I have a whole playlist on geothermal greenhouses and lots of videos on there. So not necessarily pictures per se, but lots of videos. Electric costs to run fan 24/7. I cover that in my ultimate greenhouse walkthrough. It's minimal. It's I don't know, maybe a couple dollars a month, at $5 at the very, very most. Because again, you're running at very low speeds on a fan, and there's very little resistance. Let's see, can you run fans using solar and wind? You can, share, if you've got a battery attached to that solar or wind. We're running everything here on my property 100% off solar. We're completely off grid. And so, yes, we're running our fans on solar. You'd need to be able to store that power in a battery or battery bank in order to run the fans at night. And we are located in, we're in Idaho, yes. Let's see, how are you attaching the side pipes? Are you using wood on the side pipes too? We're using wood on the side pipes at the bottom, the 2x6, as Doug mentioned, and the 2x4 at the top of that side pipe. And that's what we're using to put the wiggle wire on to hold the plastic. That's what we're using to put the animal netting on. Yes, so you will need lumber on the sides. Okay, can the greenhouse plastic be welded or joined to make bigger sheets from smaller? Would it make sense to join what would normally be 4 20 by 40 foot greenhouses into one 80 foot by 40 greenhouse? You can use tape. I don't know that you, there may be ways that you can melt it together. I don't know. I know they have, I would use Gorilla brand clear tape. And that's what I use in my greenhouse when I get holes. Let's see. Where did you get your perforated pipe? I bought mine at Home Depot. You bought yours, Doug?
I ended up driving up to Menards in Casper, Wyoming. It was half the price.
Menards, hands down, has the best price. Okay, I think that is it. So, Doug, thank you so much for your time here. Best of success. I'd like to stop by. I'm teaching a beekeeping class this Saturday, but when I get done with it, I'll give you a call, see if you're digging a hole, and I may just swing by and see how things going. So we'll give Doug a few days, maybe even a week or so, to get things underway, and then we'll have our next updated video on what he's done, what it was like. You know, this is all theory for Doug right now. and we'll see how it turns out in practice. Thank you so much for being here. If this information was helpful, please, would really appreciate it if you give us a thumbs up and like it and share this with other people. Feel free to post this on your Facebook or other social media so people can get this information. There are a lot of people who are very serious, like Doug, who want to be able to grow food for their families year round. We understand as husbands and fathers that it's our responsibility to provide and protect. And this is one way that we can provide food for our families. Doug, any last words?
No, other than I just want to say thank you for doing a lot of the trial and error for us. I know that you've spent a lot of time, a lot of money, and a lot of effort in figuring some stuff out. So it's actually very helpful to see somebody that's done it and to learn from their mistakes and their successes. So thank you.
Glad to do that. And that's why I have the channel, is to help people get prepared and save time and money. I share what works, and I would have 1,000 videos if I shared what didn't work. So I'm just trying to share what does work and help you get there to your goals as quickly as possible. Thanks everybody for joining us this evening. We're going to sign off. And as always, this is LDS Prepper reminding you, if you are prepared, you shall not fear. We'll see you on the next video as Doug progresses through his process. Thanks a lot.